Volcanoes are formed by magma that leaks out of the mantle through a crack in the lithosphere. Once the magma escapes, it cools, forming rock. That accumulation of rock forms a volcanic mountain. This volcano, of course, is in the middle of erupting. We can see the magma spewing out of it. That makes it an active volcano. Scientists generally consider a volcano to be active if it's erupting, like the one shown here, or if it's showing signs that it might erupt soon. Increased earthquake activity around the volcano, or a change in the kinds of gases being emitted by the volcano are typically signs of impending eruption. In a given year, about 50 or 60 of the volcanoes above the ocean's surface are active. However, the vast majority of active volcanoes exist below the ocean's surface, and that makes them a little hard to study. Throughout recorded history, about 539 of the volcanoes that exist above the ocean's surface have erupted at least once. There are basically two ways in which volcanoes erupt: explosive eruptions and non-explosive eruptions. During an explosive eruption, the magma is ejected forcefully from the volcano, being thrown upwards and outwards. This is obviously an explosive eruption. Non-explosive eruptions are a little more, quote, gentle, unquote, because the lava simply escapes from vents on the sides of the volcano. The energy associated with volcanic eruptions is truly outstanding. For example, in 1980, Mount St. Helens erupted in the state of Washington. That eruption had as much energy as the explosion of 10 million tons of TNT. With that kind of energy, it's not surprising that volcanoes can make massive changes to the geology of their region. In the aftermath of the Mount St. Helens eruption, for example, scientists found huge walls of rock that had been formed overnight, and a huge canyon that was cut through solid rock overnight. The more we study natural catastrophes like this, the more we realize how quickly geological structures can form.